Hello everyone, I welcome you all in today's video. Today I am going to start with the biochemistry unit from the CSIR Net Life Science syllabus, and the first topic we are going to discuss about is the atom and the chemical bond. So let's get started. Starting with atom. What is an atom? It's the smallest unit for the matter. Any matter is made of atom, we all know that. The basic size is in nanometer scale, 0.1 to 0.5. In biomolecules, basically, the electronic distribution is very important because it's the one reason why bonds create. So let's understand its structure. In the diagram you can see here, it's the structure of an atom. At the center, there are present proton and neutron. Proton is positive charge and neutron is neutral. That's why they are together form the nucleus. The nucleus is overall positively charged, and around it electrons revolve in electronic shells, and these electrons basically carry the negative charge. This is the basic structure. Why this is important? All the bonds based on the concept of the stability of the atom. So let's get moving. Next, elements. First, when elements form, how they are formed basically? When together different atoms combine, they form molecules. When same type of atoms combine, they form the elements. This is the basic thing. Now elements in biology, first let's go back to the track. How many elements are known till now? 118. 118. So here down below you can see the periodic table of elements. You all know about the metal, non-metal and other halogens, all the concept you already know. From these 118 elements, 92 elements are basically found natural in the ecosystem, and 26 elements are not found in the nature, but they've been processed and synthesized in the laboratories. But only few out of these all elements are present in the living system. If an average I say, it's 24 to 25. Now a code you must always remember, CHNOPS, CHNOPS. What is this code? It basically tells you the most important or dominating elements that form the biological system. These are the carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. Let me tell you a short coming story which you can relate. When life forms on the planet of Earth, how basically things happen? We say that biological things start only when chemical reactions happen. That's true. That's why the first topic of our unit of life science is biochemistry. That's why it is related. So you must take interest into it. All these CHNOPS or the group of these elements which I have just told you, these 6 elements, they form 98% of the living matter. Why? Because they are the one which are able to form the stable covalent bonds, especially the carbon, nitrogen and oxygen. You will understand more about their bonds in the coming chapter, in the coming videos I will post. So why this is important? Why we need a stable bonds? Because if we are going to survive, we need stable structure, stable organization, and for that these are the most accurate candidates. Few trace elements are also important like iron, zinc, copper, magnesium. Why they are important? They are part of our enzyme system or they are part of proteins. That why their deficiency or toxicity may affect our biological system. So that's why elements are also important in the biology. Moving to next, the atomic number and mass number. Atomic number represented by a Z letter. What it says the number of protons present in an atom. That is the positive charge basically. The mass number is represented by A letter, and it is the sum of protons plus neutrons. Now you just again see the word atomic number, mass number. Why the number here? The atomic number defines the number of an atom. Why? For the stability of an atom, the number of electrons and number of protons put down to be equal, because equal charge when there, so stability will be atom. 6 electrons, 6 protons, like that way. So that's why the scientists denote it the atomic number, mass number. Now you see proton and neutrons both are present in the nucleus, and you know that the atom mass basically defined by its nucleus, because electrons are too light that they cannot give much to the mass of the atom. That's why scientists denote it as the mass number. So this is the story behind it. I love telling the story because it makes the science more interesting. Moving to next, the neutrons. Now we are talking about electrons, protons. What is the role of neutrons? Why are even there? They have no charge, they are just present, they are giving the mass. What's their role actually? Why are they present? Why nature basically formed these elements, these particles, sorry. So neutrons are the difference of A minus Z. Why A minus Z? As I've told you, A is basically nucleus part, Z is basically the stability part, and stability is more for the electrons, and the number of electrons are same as that of the protons. So neutrons are basically those particles which define the nature of that particular atom. So it's the difference of A minus Z, that is mass number minus atomic number. Let's take a quick example here. Carbon 12, its Z is 12 and its Z is 6 and A is 12. So Z6 means, already you know that 6 protons, 6 electrons, and the neutrons basically A minus Z is 6. So it's the perfect atom having all balanced elements. Atoms with the same Z but different neutrons are isotopes. You know that what are isotopes? So they have same Z but different neutrons. So we are going to discuss, like here is example of carbon. Carbon 3 isotopes are given: carbon 12, carbon 13, carbon 14. Carbon 12 is commonly found in the nature. It's like 6 protons, 6 neutrons. In carbon 13, 6 protons, 7 neutrons. Now what is this 13? If you just see here, it is the mass number, and the number of protons basically presents the atomic number. So if you subtract those, you will get the number of neutrons. So this is how the isotopes are formed. Now let's understand more about these isotopes, and there are two other categories, isotones and isobars. Already told you isotopes have same Z, that is atomic number, and different neutrons. Isobars, bars basically when you calculate the mass, it's basically if you want to remember. So isobar basically same mass number and different Z. It is always going to be for two different atoms which have different mass number, different atomic number, sorry, but same mass number, like 14 carbon, 14 neutron. The 14 represents the mass number, that is same for those. Isotones, they have same number of neutrons, so they are isotones, but different Z. Z value will be different over here. So you can see here 14 carbon, 15 nitrogen. How to calculate neutrons? Again you know that A minus Z. Isotopes are widely used in biology. For example, radioactive tracers. Tracer elements are those which are going to help you to calculate the age of particular specimen, particular fossil. So these are the tracer elements. So you just go for if that particular fossil at one point of time must be living. So in the start of life, these are the elements which discover the life, and after the life ends, these are the only elements which help to trace the lifetime or the age of that fossil, because that fossil already carry those elements. So you just go and check their half life and you will get to know, but these elements should be radioactive in nature. Let's go further. Isobars show same mass but different chemical properties. Of course, as I've already told you, in isobars there are going to be two different type of atom, and two different atoms will have different properties. Here is a quick difference table for isotope, isobar and isotone. Already I have told you the most of the properties. You can go through these. The simple definition, the protons, neutrons, the simple examples. Now for the biological use I must go. If you can see here, in the biological use, isotopes I already told you they are used in the tracing process. Isobars are rarely used because they are going to have two different chemical properties, so we are not going to use them in anywhere. Isotones may be used but rarely. Mainly they are used in the nuclear physics, that is not our part. Moving on to the radioisotopes that you were asking. So it's also important. How radioisotopes form? I've already told you, when atom is stable, it has a stability, it will be found in a silent form. Silent forms means it is not going to emit any form type of energy. But there are certain atoms which are very unstable. They are unstable because their electrons are carrying higher energy, because they are not present into the lower shell, they are present in the higher energy shells. So when they are present in the higher energy shells, they need to emit the energy, so that by emitting that energy they lost some amount of that energy and come back to a stable lower electronic shell. This is the basic process. I hope you understand this. If you don't, just let me know in the comment section. I will make a video for that particular understanding. So basically, when they come into a stable state, from that higher energy shell to the lower stable energy shell, the difference in that creates a high energy emission that is caused by the radiation. That is a cause of radiation basically. These are types known as radioisotopes. Why isotopes is written? Because the element, so the atom, all the atoms of a particular element, like I am talking about phosphorus, not naturally occurring phosphorus is radioactive, but one of its isotope is going to be radioactive in nature, and you know that what are isotopes. Now type of decay, what type of energy they are going to emit, which type of process they are going to follow to get back to the stability, it defines the type of decay. So it will be alpha decay, beta decay, gamma decay. In alpha decay, helium nucleus will be emitted. So there will be a change in the energy. You can see in the table what change is there. Z will be decreased by 2, A will be decreased by 4 because a complete helium nucleus is out. And the penetration power is very low. Penetration power is very low means it is very low energy type of emitting radiation. So it's not that harsh for us, it is very low in penetration. So it is used in the radiotherapy like in cancer treatments. Second type is the beta. Beta has basically two types, electron or positron. Now what is positron? Positron is not proton, you must know, because proton have a different mass, electron have a different mass. But when a particle having same mass as that of the electron but opposite charge, that is known as a positron. So when an electron is emitted, Z will be increased by 1 because one positive charge enhanced, because the balance structure is going to be reciprocated, releasing one negative charge. A will remain same. Again, its penetration power is very moderate, so it can be used in tracing and dating process for the carbon dating type, like carbon and nitrogen you can see here. In positron, again a positive energy is emitted, so minus negative, that means one electron negative charge has been increased. A will remain same, other penetration power is again moderate. It is used in PET scans. Scanning process is also based on the penetration ability, so it is used in that, again in the biological purpose only. The gamma radiations, which are the highly penetration, very high energy carrying. Why high energy? Because they emit a photon, and photon is so light. When something is so light, you cannot just detect its weight actually, so how much fast it can travel, you just know the concept, right? The higher the mass, the less it will move, it will difficult to move. So the lighter the particle, it will move more fast. The photons travel the fastest, that's why these have the very high penetration property. It can also be used in cancer therapy in a controlled environment and in sterilization also. So these are the type of the decays which are introduced or understood under the radioisotopes concept. Now for all these concepts you have just understood, our main aim is to understand about atoms and then moving forward to the chemical bonds that I am going to cover in the next video. So this is the last topic that I am going to cover. almost last, one more topic I think after this. So what this will tell how all the things I have just told you related to the chemical bonding. You can see here in the diagram, it's a Bohr atomic model. In this model you can see again same photon plus neutron in the green color at the center. Then there are different shells. Now you need to understand the electron shells. The electron shells were given name like K, L, M, N and O. And in each of these shell, a N number is given 1, 2, 3, 4, 5. In each shell, how many number of electrons will be there? It is given by the formula 2n square. So, for example, we take oxygen. Oxygen has Z, that means number of electrons or protons, that is 8. So, it will go with 1s2, 2s2, 2p4. So, this is the rule. Now, what are these small s and small p? They are the subshells of a single shell. Shell is represented by K, L, M and O, and S, P are basically representing the subshells of these shells. So, when Bohr discovered the atomic structure, he said that electrons are just not present in a single shell, but this shell is also further divided into subshells which also have different energy and different orientation of the electrons. Like S shell, you know, in the chemistry it is spherical in structure, so spherically electrons are distributed. In the P shell it will have a dumbbell like structure, you just remember all that, right? So that just basically in for our biology concept, I am just going to tell you that even in a shell the different electrons will have different orientation, different energy carrying capacity, and depending upon in which subshell or shell the electrons are present, the type of bond is going to be formed. So that's what I am going to make you understand. So stability is basically when the octet rule follow, means when 8 electrons are present in the outermost shell. The outermost shell, like in this diagram, N5 is the outermost shell. If this outermost shell is filled with 8 electrons, that means it is the stable atom. So this is about the electron arrangement according to Bohr's atomic model. And one more concept linked to this is the electronegativity. This is again going to help you how the bonds form. So it is the tendency to attract the shared electrons. Now I say in every atom the octet rule must follow. Every atom try to be stable, like you as an individual want to be stable in the life. Same goes with atom. They don't like high energy and stability, they also want stability. So for that stability, if they don't have the octet or 8 electrons in the outer shell, they try to come close and form bonds with the other same type of unstable atoms or different type of atoms to form elements or molecules or compounds. So for that matter, the process by which this happens is the electronegativity. So electronegativity in the periodic table, when you move across, it will increases. As you can see the red arrow, you grow from left to right, it increase. But as you go down the group, it will decrease. So highest electronegative atom is the fluorine. So it's basically help you to understand the polarity of the bond. If the bond is going to be polar or non-polar, that basically depends the type of atoms that are going to interact, the difference in their electronegativity. So these are the whole basic concept you must know before going into our main topic, that is the chemical bond. That's all for today. I hope you understand the topic well. Thanks for watching.